Continue on chapter 5, functions and graph. These are the learning outcome for this lesson. Logarithmic function is a function of the form fx equal to log x base a, where x must be greater than 0 and the base a is positive constant other than 1. This is the graph for logarithmic function for a greater than 1. Here is asymptote at x equal to 0. Steps for sketching logarithmic graph. First, we need to know the shape of graph. For a greater than 1, graph is from below and to the right. Positive log and positive x. And then we have negative logs and then we have positive log and negative x. So graph will move to the left. Positive log, negative x. For positive x, graph will move to the right, and for negative x, graph will move to the left. And then we have negative log positive x. So graph from above and to the right. This graph is for negative log positive x. And last one will have negative log and negative x. Negative log, negative x. So these are the shape for log function. Then we have asymptote. Asymptote for logs is the function inside log. Let's say function is log a x minus b. Then x minus b here is the asymptote equal to 0. So asymptote is x equal to b. Sketch the graph and find the intercept if the graph has any intercepts. Example, sketch the graph of the following functions. From the graph, determine the domain and range for each of these functions. For fx equal to log x minus 1, shape is positive, so from below to the right. Second, asymptote function inside log is x minus 1 equal to 0, so asymptote is at x equal to 1. Sketch graph. Asymptote is at x equal to 1 is here along the y-axis. Graph is from below. The graph fx will not cross the asymptote. The graph is close at the asymptote but do not cross the line. So from above to the right. The graph cross at axis at y equal to 0. When y equal to 0, log x minus 1 equal to 0. X minus 1 equal to log move to the right hand side, 10 power of 0. So equal to 1. Then x equal to 2. Therefore, the intercept is 2. Then lastly, don't forget to label the graph. Domain for f is from asymptote 1, not included. Since the graph cannot cross the asymptote, so asymptote is not included. Open bracket and then move towards positive x, so up to infinity. And range of f is from below negative infinity to infinity. Next example, fx equal to log 1 minus 4x base 3. Shape log positive, x negative. So graph is from below to the left. Second, asymptote 1 minus 4x equal to 0. So 4x equal to 1. X equal to 1 over 4. Sketch graph. Sketch graph, asymptote is at x equal 1 over 4 and along the y-axis. Graph is from below to the left. So this graph cannot cross the asymptote. Since it moved to the left, means the graph should start from left hand side of asymptote. Start from here and to above. Means this graph will cross x-axis and y-axis at any points. So calculate the intercept first, since it will definitely cross x-axis and y-axis. When x equal to 0, y-intercept log 3, 1 minus 4, 0. 1 base 3 equal to 0. And then for y equal to 0, log 3, 1 minus 4x equal to 0. 1 minus 4x equal to 3 power of 0. 1 minus 4x equal to 1. 4x equal to 0. X equal to 0. So cross at x0, y0 here. Then sketch the graph. Start from below. Close to asymptote but do not cross, and then to the left. Label the graph. This is fx. And this is the graph for log 1 minus 4x base 3. Domain of f is from negative infinity. Graph is at left hand side, so negative infinity up to asymptote. Asymptote equal 1 over 4, not included since the graph cannot cross asymptote. And range for f is from negative infinity to 0 and to infinity. Next example, fx equal to log x plus 2 base 1 over 5. So in this case, base is less than 1 and we'll have shape for a greater than 1. So we need to simplify these functions so that base 1 over 5 will be greater than 1. Simplify, change base, log 5 x plus 2 and log 5 1 over 5 equal to log 5 x plus 2 over log 5 inverse. Then log 5 negative 1 is negative 1, so divide by negative 1, negative log 5 x plus 2. This is the new functions. So sketch the graph according to this new function. Shape is negative logs positive x, so negative logs graph will move to below, and positive x, so from left to right. And then second asymptote is x plus 2 equal to 0. Asymptote is x equal negative 2. Sketch the graph. X equal negative 2 here. So asymptote is along the y-axis. Since the graph will move to the right, means this graph will have x and y intercept. So find the intercept first. For y-intercept, when x equal to 0. When x equal to 0, function y equal to negative log base 5, x is 0, 2 equal to negative 0.43. X-intercept is when y equal to 0. So when y equal to 0, function is negative log 5, x plus 2 equal to 0. Log base 5, x plus 2 equal to 0. X plus 2 equal to 50, x equal to 1 minus 2, negative 1. So the graph will cross x-axis at negative 1 and negative y. This graph starts from close to asymptote here and to the right. So here. This is x equal negative 1 and this intercept is negative 0.43 of fx. These are the graph for log x plus 2 base 1 over 5. Domain for f is from asymptote negative 2 not included to positive x. And then range of f equal to from below negative infinity to infinity. Next example, fx equal to 3 minus 2 ln x minus 1. Shape of graph. Graph for ln is the same as graph for log, so the shape is also the same shape as log. At the function ln and x here. Negative 2 ln positive x, so negative ln positive x. So graph is from above to positive x, so here. Second asymptote. Asymptote is the same function inside log, so x minus 1 equal to 0. X minus 1 equal to 0. Asymptote is x equal to 1. Sketch the graph. And graph is from above, close to asymptote and to the right. And this graph has x-intercept when y equal to 0. So y equal to 0, graph is 3 minus 2 ln x minus 1 equal to 0. So for x, 2 ln x minus 1 equal to 3 ln x minus 1 equal 3 over 2. And x minus 1 equal, move ln to right hand side, so e 3 over 2, x equal to e 3 over 2 plus 1, which is 5.48. Okay, the value here will be 5.48. And then lastly, don't forget to label the graph fx. Domain of f is from asymptote, not include the asymptote. Asymptote is 1, so 1 to infinity. The graph will move and do not stop at any point, so up to infinity. Range of f from below, negative infinity, and up to 0, up to infinity. Last example, fx equal to 2 plus ln 3 minus x. Shape is positive ln negative x. Positive ln negative x, so graph will move towards negative x from below to negative x. Second asymptote, 3 minus x equal to 0, so x equal to 3. Sketch graph. Asymptote is at x equal to 3. Graph will move to left hand side towards negative x, so this graph will cross x axis and y axis. So find the points for x and y intercepts. Y intercept is when x equal to 0, y equal to 2 plus ln 3 minus 0. So 2 plus ln 3 equal to 3.08. X intercepts y equal to 0. When y equal to 0, function is 2 plus ln 3 minus x equal to 0. Ln 3 minus x equal negative 2. 3 minus x equal e negative 2. X equal to 3 minus e negative 2, which is 2.86. Okay, so graph will cross x positive and y positive. Sketch the graph from below, close to asymptote and cross at y positive, x positive. So here is 2.86 and y is 3.09. Label the graph fx. Domain is from negative infinity to asymptote 3 not included, and range is from below negative infinity to infinity. And these are your exercises. Please submit the exercises at the end of lecture.